Good afternoon, everyone. My name is Kepa Barrett. I am a senior here at Pitzer College studying environmental analysis and economics. And on behalf of the Pitzer College Robert Redford Conservancy for Southern California Sustainability, we are pleased to welcome Dr. Juliet Christian Smith as she delivers the John D. Sullivan Memorial Lecture today. Dr. Christian Smith is a senior climate scientist at the Climate and Energy Program at the Union of Concerned Scientists. She is a lead author of the book, A 21st Century U.S. Water Policy, and an editor at the Journal of Sustainability Science. She is also a member of the Directors Council for the University of California's Water Security and Sustainability Research Initiative, as well as a board member of Ag Innovations. Her work is focused on providing policymakers and the public with robust, accessible, and relevant information on climate science and its impacts. Everyone, please give a warm welcome to Dr. Juliet Christian Smith.
Okay, can everyone hear me? I'm so happy to be here today to honor the legacy of Professor Sullivan. And I'm going to be talking today about climate change. And the reason I call it La Madre is because the press and the media are a big part of how we understand our world. And 2 years ago, you might have heard about the Godzilla El Nino that was headed our way. Does anyone remember that? Okay, it never came, but nonetheless, there were hundreds of articles written in the LA Times with the term El Nino in it that year. And there were 0 articles about water with the terms climate change in them. So I said, media loves names, fun monikers for things, Brangelina, La Nina, El Nino. Let's call this La Madre because it's not a single weather event. It's not a small weather system. It is a force that's changing our future and it's currently changing our water system in a way that we can perceive. We've seen major changes over time. Our peak snowmelt is 30 days sooner than it was historically. And yet our systems, our political systems, our institutions are still managing for the past. So that's what I'm going to talk about today. I just want to tell you a little bit about where I'm from. Has anyone heard of the Union of Concerned Scientists? Okay, a few people, that's great. The organization has offices in Oakland, Chicago, DC, and Cambridge, Massachusetts, but we were based in Cambridge, Massachusetts for many years, so sometimes we're not as well known on the West Coast. And we came out of a force on campus at the Massachusetts Institute of Technology. In 1969, faculty members and students were really concerned about seeing a lot of research money going to developing weapons systems in the sciences. And they said, we'd like our research to be used in ethical ways, and we'd like our research to go to solving some of the problems that we see as being the biggest problems society faces. And that organization that started with students and faculty became the Union of Concerned Scientists. And now, more than 40 years later, we're still using rigorous science to put solutions in place to try to create a healthier planet and a safer world. And the work I do at the Union of Concerned Science is in our water and climate program. So something I've been thinking a lot about since November 5th is infrastructure. So take a little tour with me back in time to 1906. This is San Francisco, Union Square, looking down towards the Embarcadero. There was a massive earthquake that killed thousands of people. A similar magnitude earthquake occurred in 1989. This is the same location. I overlapped the pictures so you could see actually the building that was rebuilt there in the back. Just take a look at the physical infrastructure, how much more of it there is. There were only about 60 people who died in this earthquake. They were mostly on the Nimitz Freeway, an older highway that hadn't been upgraded. What do you think happened between 1906 and 1989 that led to this difference in physical infrastructure safety? Does anybody have any ideas? Science, that's a good, but that's a safe one. Anything more specific? Yes?
Building codes.
Building codes, yes?
Public asked for it.
Yes, there was public pressure that led to changes to building codes. And now we build our buildings to withstand violent seismic events. I'm going to come back to this because we do not build buildings to withstand an average earthquake. We do not know when earthquakes are going to come. We do not know how big they're going to be, but we build our buildings now to withstand violent seismic activities. That's part of engineering design specifications. And so really the question I'm going to be posing through this talk is what kind of future are we preparing for in the state of California right now when we think about how climate change is changing our water. So really, if you look at the data, we see climate change as fundamentally changing our entire water system. That's partially because our water system was built at a certain time for certain purposes. And really, what this assumes you know about California water, which I'm just going to go over really quickly, is that we get most of our water in the northern part of the state. And we have to transfer it to places like here in the southern and coastal parts of the state where we have the most people using water. And that system relies on a bunch of dams and reservoirs in higher elevation areas that capture snowmelt. And snowmelt composes about a third of our water supplies. So what happens when snow does this? In 2012, we began a drought period that we saw the lowest record levels of snowpack we'd ever seen before. This was much drier than our climate models projected. And I wanted to point out here that climate scientists have been modeling a shift in our snowpack, reduced snowpack because of warmer temperatures, so more precipitation coming in the form of rain rather than snow, for many, many years. And all of that scientific modeling didn't project this level of drying this soon. In addition to more droughts, the flip side of climate change is also more extreme wet weather events. Warmer air holds more water vapor, and more water vapor in atmospheric rivers like the ones that affect the California coast means much more intense precipitation events. Maybe like the one we're going to have today, we'll see. It hasn't started off that bad. And does anybody know what this is a picture of? Yes, the Oroville Dam. The other aspect of the shift that we're seeing is that when we have storms, cold storms can come in and dump a lot of snow. But if they are followed by warmer storms, that snow can melt very quickly. And that's exactly what's been happening. As I mentioned, we're seeing the peak snow melt now 30 days sooner. And that's what's projected to happen out to the end of the century. Research that's currently in peer review that was just brought to the policymakers in January, presented by Dr. Alex Hall of UCLA, shows that he is modeling the peak runoff of snowmelt moving to January by the end of the century if we stay on the current emissions trajectory. What that means is we're getting a lot more rain and snowmelt coming into our reservoir systems, and we're having to use things we never used before. Emergency spillways, main spillways, that one broke. Emergency spillways, which is really just a hillside. And we're not prepared to use these safety valves, release valves, for the kinds of extreme events that are headed our way. So, one of the things that we've been working on quite a bit is how all of this is changing our groundwater. We have extreme wet during certain periods of time. Then we have long, dry periods. And in the middle, we have a huge reliance on groundwater. So this is something that we've never actually measured, because in California, we haven't regulated groundwater until 2 years ago, and I'll get to that in a minute. So it was really the deepest pump, the deepest well, as much as you can pump, that's the winner. And what we did was the Jet Propulsion Laboratory at NASA actually sent out a satellite to measure how our groundwater use is affecting the gravitational force, the pull on Earth. And these are the images that came out of that experiment. It's called the GRACE satellite experiment. You can see in June of 2002, the green color is a higher groundwater level, and the red color is a very low, declining groundwater level. From outer space, we can see the damage we're doing to our groundwater aquifers in the Central Valley of California. We're on par with 2 other areas of the world in terms of how quickly we're depleting our groundwater aquifers. Areas of India where there is irrigated cotton, and some areas in China. This is another way of seeing that same data. This is our cumulative groundwater declines in the Central Valley aquifers over time. 1965 over on the left hand, all the way to 2015. The yellow periods are periods of drought, drier periods, and the blue hues are periods of wetter than normal precipitation. So you can see that groundwater levels change. When we have some rain, they can fill back up. But over time, we have been withdrawing much more than we can recharge. And in fact, we withdraw about 1 million acre feet more than we can recharge every year. There's about 3 million acre feet that's stored in Lake Oroville for comparison. So about a year ago, I guess, 2015, yeah, a year and a half ago, we wrote a piece on this called the Big Water Supply Shift. And what we said was, looking at the data on how we use water in California, what we're seeing is during droughts, a huge shift away from our traditional surface water supplies towards groundwater. We're seeing a big increase in groundwater pumping. And we haven't been measuring it because we don't meter groundwater wells. We haven't been regulating it because we don't have any real legal system around groundwater. And we haven't been thinking about how this is impacting a lot of other things that we care about, such as land subsidence. Has anyone ever heard of that? So land subsidence is when the earth actually falls, the soil sinks in areas where the groundwater has been pulled out and the pressure has been reduced. It's like a sponge kind of shriveling up in the sun. And once it shrivels, in this case with the soil, you don't actually get to pump it back up. You lose that aquifer storage space forever. So we put out this report, the Big Water Supply Shift, noticing that with climate change and with long periods of decreased surface water, we're seeing an increased reliance on groundwater, and we should probably think about how to address that. Just 2 weeks ago, a series of scientific studies came out, and they were reviewed by this paper by Jason Gerdak at San Francisco State University that shows that you can actually quantitatively see climate-induced groundwater pumping. Basically, during dry periods, we're seeing worldwide a shift towards groundwater. And this has big effects on local groundwater levels. So the red areas here are areas that are losing groundwater about 50 to 60 feet a year. And this is some of the poorest areas of the state. And in those areas, we're seeing emergency services have to bring in bottled water, cisterns, tankers, to just bring basic drinking water to these communities that are groundwater dependent. A lot of these small communities have private wells or school districts that have small wells, and those wells are usually the first to go dry because they're shallower than the agricultural wells. Tulare County was ground zero, and you might have seen a lot of media about this during the drought in terms of the number of people who didn't have running water for dishwashing, for just general health and safety. There were concerns that Child Protective Services would come into the homes that didn't have drinking water. So there are a lot of stressful things that happen in people's lives when their drinking water runs out. 10 tons of emergency services going into these areas, but not really with long-term solutions. It was in this environment that the Sustainable Groundwater Management Act passed in California. And this is at the signing ceremony, Jerry Brown. Behind him is Fran Pavley, a senator who has been a champion of water issues for a very long time. She and Roger Dickinson, who's over there, they co-authored the legislation. And this legislation for the first time said we actually need to have a statewide approach to how we deal with groundwater, which now comprises more than half of our drinking water supplies in the state. And the law said we need to identify areas where year after year we're using more than we replace. These are critically overdrafted basins. And we have to develop new agencies. They're called groundwater sustainability agencies who have to develop plans that put these basins on track to achieve sustainability by 2040. All of this is creating jobs, by the way. We say every time a GSA is created, a consultant gets their wings. And finally, the big difference is that it creates a state enforcement mechanism. So before, people could write plans, and they did. They said, okay, we want groundwater to be better. Now they have to have quantitative targets to say exactly how much better is their water quality going to be, exactly how much more water will they be putting in than they take out. And I just wanted to note one other thing. This is the picture that everybody always uses to talk about what happened in the Sustainable Groundwater Management Act. Here are the people who attended the event, and you have Senator Pavley there in the middle, Assemblymember Dickinson there in the back, and a bunch of the advocates who worked tirelessly to put this together. And you might notice something about the difference between these two pictures. That'd be you. I'm not saying anything. Okay, so one of the things that the critically overdrafted basins, this map had to be developed by the state, and it was just recently developed. It says, where are the groundwater basins that have really severe problems? They have declining groundwater levels year after year. You can see that they're concentrated in the southern San Joaquin Valley, with a few along the central coast there. You might be surprised that the year after the bill was passed, the number of new wells that were permitted in those same counties were at record levels. Almost 1,000 wells were permitted in Tulare County, where it's critically overdrafted, and there are a lot of undesirable results like land subsidence and domestic wells going dry, as we already talked about. So one of the things that the Sustainable Groundwater Management Act did not do was it did not change the process by which permits are given out. So even if we know now, or the state has declared this basin as overdrafted, there's just no more groundwater, that doesn't mean that the counties aren't still under a lot of pressure to allow people to drill new wells who live locally and want to make sure that their crops, in most cases, don't get dried out by the next drought. We have a lot of situations like this where we have a big disconnect between the information that's available and what's happening on the ground. I'm going to give you another example. The California Water Commission is an entity that is giving away $2.7 billion from the last water bond that we all voted for in 2014. That money, it was, I think, an $11 billion bond. Total $2.7 billion is going to new water infrastructure. The draft regulations around what they were going to look at to evaluate whether they would give money to projects did not include the term climate change. We worked a lot with them on that. But there's a bit of a juxtaposition here in terms of California being known as one of the leaders on climate change mitigation. We have the most aggressive carbon emissions reductions in the nation. We're on par with the European Union's emissions reduction. And yet when it comes to adaptation and planning, we are just beginning. So again, what future are we preparing for? Are you ready for some good news? Okay, I have some good news. One of the things we did with the California Water Commission, and in a lot of the work that we do, is we combine scientific analysis, with advocacy, with engagement from our members. We have over 500,000 members now, and we develop strategies to get results. And one of the things we did with the California Water Commission, an organization that really didn't have much of a presence with the public, didn't really get any public scrutiny or review, is we told our members about what was going on. We said, hey, they're looking at these new, long-lived infrastructure projects. These things are going to be around for 50 to 100 years. They're going to spend millions, if not $1 billion, on some of these projects. Wouldn't it be nice to know how they might work in wetter wet periods and drier dry periods? Wouldn't it be nice to know that the money that we're spending right now will continue to deliver public benefits in the future? And we were frankly shocked, because a lot of our members are really interested in things like clean vehicles and Teslas and renewable portfolio standard and solar panels. We were really surprised that over 3,000 of them decided to do that, to send a letter and say, hey, California Water Commissioners, we're interested in you taking a look at climate change. So many letters were sent, actually, it shut down their server, because as I mentioned, they didn't have a lot of public review. That was a little bit embarrassing, but the point is that the final regulations did include climate change, and they're now kind of setting a pathway towards the approach that agencies can take to take scientific information, taking downscaled projections, and providing localized information that water projects can use when they apply for funding. And it's actually pretty hard to do that. It's harder than I really imagined at the beginning of this process. Getting all of the great climate science that we've invested in as a state and that we've put together into the hands of decision makers at the right time, at the right scale, is a challenge. And that's one of the reasons why, more good news, we passed a law last year, Assembly Bill 2800. UCS sponsored this bill, and it was to create a new working group that brings together state engineers and climate scientists to think about what actually needs to change in our engineering design specifications, what actually needs to change in our infrastructure planning and funding to allow us to adapt to this climate information that we already have. And then last week, State Water Resources Control Board came out with a climate change resolution, which is something we've been working with them on a bit over the last couple of months. And it said that this agency is going to commit to using relevant climate information, relevant data, in all of its permits, plans, policies, and decisions. So this is going really above and beyond what is required by law right now. I'm going to end with a sort of back to the future moment. This graphic you might not be that impressed with because it's from 1988. This was in Discover magazine in 1988. And it summarized the dissertation of my former boss, Peter Glick, which was saying that if atmospheric carbon dioxide levels double, the mountain snow that supplies much of California's water will dwindle, creating winter floods and summer droughts. So this is probably before a lot of you in this room were born. We've had this information, and we just haven't been using it. As an organization, what we're really trying to do is not only get science into the decision makers' hands and into the policy makers' requirements of what they have to look at, but we're also trying to develop a set of solutions. And again, we come back to groundwater, because the thing about groundwater is, if you're losing a third of your water supply, snowpack dwindling, expected to be 70% less by the end of the century, we don't have enough space above ground to put all that water. We already have 1,300 dams. We've dammed most of the appropriate sites to dam. There might be a few more places that end up creating reservoirs. But the vast majority of space that we have is really in those underground aquifers where they have huge amounts of unused storage because they've been drawn down. And right now, there are researchers that are looking at how do you recharge that groundwater. Not all soils are equally transmissive. You can even use cropland. So this is Professor Dahlke at UC Davis. She's doing experiments with almond farmers to see how using their dormant trees during the winter, allowing it to flood, can recharge the groundwater, and how does that affect groundwater quality, and how does that affect other aquifers nearby. That's, she's got a probe there, she's monitoring all this. It's not a pie in the sky. Kern County already figured this out. Over a decade ago, it bought a groundwater bank from the State Water Project for a really good price. And it is banking right now, I think it's around 700,000 acre feet of groundwater. And so that means that they're allowing it to recharge naturally through precipitation and stream flow, but they're also injecting groundwater down into the aquifer, and then they are pumping it out at different intervals when there's dry periods and we need that groundwater. So we really see groundwater as kind of the next frontier of water management. The 20th century was dominated by surface water supplies. It was all about dams and reservoirs. We think that the 21st century needs to start talking about groundwater. There's a lot more space. It's a lot less environmentally damaging. There's no evaporative loss. With warming temperatures, we're going to lose a lot more from our reservoirs. There's no methane emissions. We also have methane emissions from reservoirs. And so this is something we're looking for policy solutions right now. The science is still emerging, so there's a lot of work for scientists in these areas to figure out how to do this the best ways. But when you leave, these are the things I want you to remember from the talk, if you don't remember anything else. That climate change is worsening both floods and droughts in California. That less snow and more rain means less water can be captured by the existing system. We just physically can't hold it back. And if we try to, our dams are in trouble. So it's a bad idea. Better groundwater management is key to adapting to both of these extreme events. And that our infrastructure and our policy really needs to be planning for the future, not the past. You can join us. You could become one of our 500,000 members. That's where you do it. And the last thing I wanted to mention for this audience is that we have something called the Science Network. That's about 20,000 experts who have advanced degrees or are working on degrees in really any kind of field, who are interested in using their expertise for policy relevant issues. And things we do with the Science Network, we connect them to community groups that need technical answers. We bring them up to Sacramento for policy days to talk to policymakers. We engage them in writing comment letters for all the public comment periods. For instance, when we did that California Water Commission letter, that was reviewed by members of our Science Network to make sure that we had everything right. And these folks are really a huge part of our science communication, which is something we provide webinars and trainings in how to communicate about science to lay people and really get science outside of the academic sphere and outside of the reports and get it being used. So thank you so much for inviting me. I left a lot of times for questions, as Brenda had instructed me to, and I look forward to your questions. Thanks.